Good morning to all. In this session, we are going to study about assembly language programming. In the previous session, we have studied how the coding will be for every instruction we are writing in the assembly language, and how machine understands what it need to do and what it not, depending upon the codes and depending upon the instruction formats which follows this 8086 microprocessor. Today we are going to study about assembly language programming. So before going into that one, what are the disadvantages of machine level programming? See, the first important point is it is very complicated and time consuming, because it needs to code it once, decode it once and again encode it in order to get the output to the user. So it is time consuming as well as it is complicated if the instruction is 6 bytes of data. Second one, the chances of error are more. If we will not code properly, the machine can't be able to understand properly and it will not give the output correctly. So the chances of error are more. Next point, debugging a program is more difficult. Yeah, whenever we are going for the debugging for a machine level, for a binary programming, it's very difficult to encode and again decode it. So debugging a program makes more difficult, and programs are also not understood by anyone. Whatever the programs, machine level programming is written, it will not be understood by anyone, and the results are not stored as it is a not user friendly form. So these are some of the disadvantages of machine level programming. This is the reason why we are going for assembly language. The one very good advantage is it's not complicated. With the help of simple instructions we can able to understand, we can able to write the program by not making complicated, and there are chances of error also very less, and the debugging is also very easier with the help of an assembler, which we will going to see in few minutes. So what are the basic ALP development tools we require? So whenever we are writing a program, assembly language program, our 8086 microprocessor uses some tools in order to do step-by-step execution and get the user-friendly output. So what are the tools required? The first one is editor, second one is assembler, third one is linker, fourth one is locator, fifth one is debugger, and the sixth one, last one, emulator. First, editor. So what editor does? Editor is useful for writing a program of assembly language, and make sure you are saving with .asm file, .asm extension, assembly language programming. Second, assembler. The purpose of assembler is it assembles the written ALP program and decodes it for the machine understandable form. Third one, linker, links the various library files being involved in your assembly language programming. It links the various library files, various object files. It locates the files where they are and will be matching with the machine understandable language. And fifth one, debugger, it checks for the, or it debugs your program, and emulator will be providing the output to the user. These are the various tools we require in order to develop, in order to write a program in assembly language and get the output using 8086 microprocessor. So how it does? It is the process of first editor. Editor nothing but assembly language program text written in any text editor, which we can able to write in any text editor and save it as .asm. So when we are saving as .asm, it gives to the assembler. Now the assembler will be checking what program he has written, and it will see for the any error messages. If any error messages occurs, it again go to the text editor saying that this has the errors, please check it. If it is okay, if we don't have any errors, then it goes to the linker. Linker will be linking the other object code modules from binary. What assembler does, it will check for errors and it will provide a object code module, nothing but in binary. Again I am telling to you, assembler purpose is checking for errors and decoding your program into machine level or binary level module. Now what linker does, it will link the other object code modules from library and will be getting some linked modules. Then we will be going, this linked modules will be checked by the locator, and the loader is nothing but your debugger. So what loader will do, will be going for debugging of the corresponding program and giving to your microprocessor. It will understand it and will be emulating the output, and the time will be taken, which is called as execution time. So this is how our processor will be executing assembly language programming. First, editor, writing the program in text editor, then assembling the text editor, assembly language program, checking for errors. If no errors, it will create an object module which is in binary language or machine level language, will be linked to other library files, library modules, will be getting linked modules, and loader will be debugging the program and giving to the processor. Processor will be emulating the output to the user. This is the steps how the assembly language program is being executed by the 8086 microprocessor. So first, editor, as we all know, allows to create a file containing assembly program. For example, we can have PC write, word star, n number of editor we have through which you can able to write assembly program, which allows to create a file. It will save program in rhyme as we are typing. It backups the file before correcting errors. The file can be saved on any drive. We can go for floppy disk or CD drive or hard drive, anywhere. Program should be well formatted. Assembly program should be saved as extension .asm file. This is what some rules or editor follows. Second one is assembler, which translates the assembly language program or instructions to binary codes. Displacements of named data items, offset of labels are determined in the first run of code or first run of uh, cycle. On second run, it produces the binary code. On first one, what it is, what are the displacements it has, whether it is an 8-bit or 16-bit, what are the data items, what are the offsets, what are the off labels, will be determined in the first run, and in the second run, it will produce a binary code, which can be extension, which can be as .obj, and the assembler list file as .lst. So what is this list? List file will be errors are put in list file. It generates only offset address, not physical address. It generates only offset address. It does not generate any physical address. Linker or locator will be determining physical address. Clear? The first two, which useful for assembly language. First editor, second one assembler. Third one is linker. So linker is nothing but what assembler is doing is creating a object file, obj file. So linker will be linking all the object files into a one large object file. So used to combine several .obj files into one large obj file. Programs are split into modules. Yeah. Link file contains the binary code of all combined modules. Also produce the link map file, which contains the address information. Assign only relative address. TASM or MASM. These are the different companies which uses this assembly language program, produces the linker file with .exe extension. .exe extension. This is what linker does. Linker does nothing. Simple. Number of obj files, number of library files will be splitted into obj file by the assembler. Will be combining all the obj files into a single obj file and taking that obj file as linker file, converting it as linker file with .exe extension. Next, fourth one, locator. Locator is nothing but it is used to assign absolute address. It is used to assign absolute address. Fifth one, debugger. Can be used to run the program if external hardware are not used. Will load the object file to memory for debugging. It allows you to see the content of register and memory location. It allows to change the content of register and memory location. Will allow to set a breakpoint. So whatever depending upon the registers, depending upon the memory locations, depending upon the instructions, it will allow you that the registers what we have, memory locations what we have, it is free or not. And last, emulator, it is used to run the program and which combines hardware and software. So MASM or TASM you can use for assembly language programming. Now what are the different rules what we have in our assembly language programming? So they will be having some 5 columns. Naming is, the first one is address, second one is data or code, third one is labels, fourth one is mnemonics, fifth one is operands, and the sixth one is comments. So with this 6 or with this 5 columns you can able to know what assembly language program, what assembly language instructions we are able to do it. Address, we also know that address or offset of a code byte. The actual code bytes or data bytes are put in the data or code column. So we'll be having 2 segments which are data segment, 3 segments, data segment, code segment, stack segment, extra segment. So label, what is a label? Is a name which represents an address referred to in a jump or call instruction. Labels are put in a labels column. Operands column contains registers, memory locations or data acted upon the instructions. Comments tells what it functions. What is the function of the instruction for future reference. So for programming assembly language, there are a few tips. First thing is we should know what is an optimum solution for the corresponding problem. Then we need to use of proper instructions and we need to use of advanced instructions. The assembly language, there are some assembly language programming rules that we need to maintain while going for programming assembly language. First one is must be written in the assembly language programming must be written in uppercase letters. They should be always uppercase letters. The labels must be followed by a colon. For example, label, give some name and put a colon. Think that this is a label which is followed by an colon. All labels and symbols must begin with a letter. All comments are typed in lowercase. And the last line of the program must be ended with the end directive. And code ends, data ends, extra ends, stack ends. We have 4 segments: core segment, data segment, extra segment and stack segment. After completion of program, you have to write end with directive. Thank you.